So, we have been only talking about the word with respect to the frequency, with respect to TF, IDF and so on, but how do I really represent a word? Okay. So, if I have a million word, I need to represent it in some way. So, can I use some kind of an indexing mechanism to represent it, or I use some other way? So, how do I represent that as a vector is what you are going to be seeing right now. Okay. So, what I have done is I have just taken a small concise dictionary where there are about 39,000 words. It is not 13 million, it is about 3 million in all. If you look at the Google's news corpus, there are about 3 million words. In the dictionary that I am considering, there are only about 39,000 words. I want to represent each one of the word given in the dictionary in the vector form. So, one simplest way to represent that is there are 39,000 elements in a vector. Only one element of the vector is going to be 1, rest of them are going to be 0. That means, if you look at the first word in the dictionary A, that will be the first one, and then the first element of that vector is going to be 1 and rest of the vectors are going to be 0. And then if you look at a back, that is the second word in that dictionary. So, number 1 occupies the second spot in that. And then if you look at zoom, it is the last but one. So, the vector is represented, all the other elements are zeros except this one. And then if you look at the word zucchini, that is the last word in the dictionary and it is represented by the element 1 at the end. So, it is a very simple codification scheme to represent the words in an independent fashion. Okay. If you look at this, there is no correlation between ABAC, zoom or zucchini and so on. Okay. So, they are all independent, that means they are orthogonal to each other in the vector space. Okay. So, what do you mean by orthogonal? As I mentioned earlier, if you do a dot product of two vectors that are orthogonal to each other, the resultant value would be a 0 vector. Okay. So, in this case, the terms home, house, apartment, flats are independently coded, even though we know that they are related to each other. But in this case, since we are using a simplified codification scheme called one hot vector, they are coded independently, and then there is absolutely no correlation between these two, even though we know well that they are quite similar to each other. Unfortunately, when in this case, when you do a dot product, what you get is a 0 here. Okay. When two vectors are similar, the value will not be equal to 0, it will be equal to somewhere between 0 and 1. Okay. So, it will be greater than 0 and between these two values it will be available. So, if you want to represent these in the vector space, for example, the 39,000 words going to be having 39,000 axes. So, it is very hard to represent all of them, and then doing computations with respect to those axes, and you want to find the similarity of different document, it is going to be pretty hard. So, is there a way that we can compress it in a smaller fashion? Is there a way that I can represent those words so that some words which are very similar to each other could be represented in a single axis? This is something which we need to think about. Assume that there are million colors that are named. We know only about 10 or 15 or 20 names of colors, but beyond which we do not know those colors, but those colors can be represented in displays in various form, assuming that we are able to represent those colors with names. That means, just for the color alone, there is going to be so many million values or axes in that real vector space, which is going to be pretty hard. right, in terms of computation, in terms of visualization, all that. So, how do I really reduce those similar terms into smaller subspaces? How do I encode those relationship among words? So, these are the question that we need to answer in the natural language processing in order for us to move in the plane of translating a document from one to the other, create a question answering bot or creating a chat bot or anything that acts like a human in the natural language interface. So, we need to really understand the relationship among words, or the machine should be able to bring those words together in some form, so that it is able to do certain operations in the required fashion. So, the main aim of the word to vector is to reduce that vector space from so many million axes to manageable ones, and then also encode the relationship among words when we do so. So, that is a dual purpose to the goal of word to vector. So, how can we represent them differently, right? One way to represent them in an axis x and y is if you want to represent the synonyms in the same axis. You want to represent say for example, the superb, fine, great, exceptional should be in one axis. So, in this case you consider these as one axis. So, only for the reference sake I have given x and y. Okay. Here these words are somewhat similar, but in one hot vector form they are orthogonal to each other, but we need to bring them as one axis. And then we know that dog, hound and canny, they are all the same, right. So, they should be represented in the same axis. And then if you look at knowledge, cognizant, they should be represented in the same axis. So, how do we do that? So, by looking at the synonyms, we can identify those synonyms of all those words and then represent them as axis in the vector space. This is one way of doing it, but for this you require a thesaurus like a WordNet to plot that particular axis. So, you require those kinds of thesaurus to reduce the dimensionality of the space. Okay. And then we can also use another relationship called is a vector. Okay, is a vector is something which actually tries to find out terms which can be represented by is a. For example, if you look at color, red is a color, green is a color, blue is a color. So, I can just use one axis to represent the color. Okay. And then if you look at the other one, car, bus, truck, I can represent them using one axis called vehicle. And then if you look at the cat and dogs, you can use pet. Cat is a pet, dog is a pet. So, by creating this kind of relationship, it is possible for you to reduce the vector space, so that the number of axes that you are talking about will be reduced to a larger extent. Another way is to look at it from the compositions. Okay. So, earlier we saw is a relationship, now we are looking at the has a vector composition. For example, if you consider a classroom, you will have a blackboard, you will have a projector, you will have students, tables, chairs and so on. So, if you look at all of those words, and then you can definitely say that okay, this may belong to a classroom. Okay. So, that composition can be used as a axis. Okay. So, each one of that, right, if you look at the synonyms or is a vector or the composition space, each one of them would be useful in doing certain operation in the information retrieval process. I will just show one example of how this could be used. Let us take one example from the E is a vector matrix. Okay. So, assuming that I have taken all the documents in the corpus and then searched for words like apple, banana, blackberry, elephant and so on. And then I try to represent those words with respect to color, animal, fruit, company name and so on. Okay. Let us take a look at the first one. Okay. Apple. Apple is not a color, it is not an animal, it is a fruit, it is a company name. Okay. So, if you go and then search Google for Apple, most of the time in the first few pages you get only the details related to Apple, the company. Okay. That is why I have just marked this. Very few documents you find in the first 10 pages of Google, you find something related to fruit. Okay. And then you search for banana, it is not a color, animal and so on. So, I am just creating a vector with respect to a matrix with respect to E is a relationship here. Okay. So, in this way I have created my matrix. Why is this and what is the use of this particular one? Let us see. Once I have created this, okay, if I search using let us say apple as my keyword. So, I am going to be getting all the documents that contain the name of the company initially. And then if you look at orange, right. So, it is the color, it is a fruit and there is also a company by that name. Okay. If the company is not very popular, okay, if the color has been used in all the documents many times, you will see a higher frequency of that, and then the probability of retrieving the documents with respect to color is more than the company name. Okay. So, this is how I represent using E is a relationship with respect to all the documents in the corpus that I have. So, what can I do with that? Let us take a very small example. There is a paragraph on the left side where you have the Apple Watch has a completely new user interface and so on and so forth. And I run this application and then mark wherever Apple is present as an organization. Okay. Wherever Apple is present, organization. Okay. And then if you look at the marking here, a key quality attribute of Apple is its peel or skin color. Definitely we know that it is not related to the company Apple, but because of the frequency of occurrence of Apple is more in that particular vector, it marked this as Apple. So, this is a wrong classification, but it is fine. So, what is the use for this? Supposing if I have taken a document set which contains all the terms related to Apple, all the terms related to the company Apple, and then I want to extract some more information with respect to the name of the person who had given the presentation with respect to new devices and so on. I want to find out what kind of technology Apple had used and when that particular document was released, if those things were available as dates and a year, and who actually gave that presentation. So, if you listen to what I said, we want to extract the organization name, organization value, we want to find out some dates, name, year and so on. Okay. Once I have run through this particular relationship and marked all my documents in the corpus in this fashion for all these words organization, dates, name and year, it is easy for me now to extract the name. So, this is called a named entity extraction. So, once I marked, I run the program, get me all the documents related to these and then extract these keywords from those document, and also give me from which document you have extracted these words. Okay, so, using this you should be able to extract. So, the purpose of this one is to first mark the documents using these is a relationship. So, I will just mark animal if there are animals found, I just write in front of that animal, okay, like this. So, this is one of the use case for this is to extract the named entities from the documents. Okay. So, with this I conclude this presentation on word to vectors. I have used these two references for this entire lecture.